So now we will be talking about the algorithms. The first algorithm is token bucket algorithm. So token bucket is a container with predefined capacity. So if bucket is full, then you cannot add any more token in that bucket. Each request for a separate user will consume one token, and it provides the separate bucket for every user. So if bucket is empty for that user, the request will be rejected. So every user has a separate bucket. When any request made for the user, we remove one token from the bucket, and after a particular time interval, the bucket will be refilled with the appropriate tokens. So now let's take the example. So if bucket capacity is 4 and we can refill the bucket with 2 tokens per minute. So here suppose if we have a client and it has 5 requests, and here suppose we are putting the token bucket. So here we have a bucket with a predefined capacity, and we have a client that will make the request. If everything is okay, the request will come to the server. So let's take the example. So suppose the bucket capacity is 3 and rule is 3 requests per user per minute. So if user make a call at 12:00, so at that time the bucket capacity is full, the request will take one token from the bucket and make the request. The first request will come to the server. So now the capacity will be 2. Now the user will make a next call at 12:00 and 10 seconds. So at that time the capacity is 2. So user will take one token from the bucket and make a call. Request will reach to the server, and after that the capacity will be 1. So suppose at 12:00:38 second another request. So at that time the capacity is 1. So user will take that token and make the call. Because it is passing the rate limiter, so the request will reach to the server. Now at 12:48 second another request from that client. So here bucket is empty because we already have used 3 tokens from this bucket. So it is empty. So if it is empty, then the request will be dropped. So here the bucket is empty, so request will be dropped with 429 error code. And then after 1 minute, it means 12:01:00, the bucket will be refilled. So total token will be 3. So we have a bucket. In that bucket, the token will be there, predefined token. So when any request will come from the client, it will take the token and make the request to the server. Now the bucket size will be decreased. Suppose initially it will be 3, then after first token will be taken, it will be 2. The next request took the token, so now it will be 1. The third request will come, took the token and go through the server. In the same minute, the fourth and fifth request will come. There is no token available in the bucket, so the request will be dropped. So if you are going to design the token bucket algorithm, so it has 2 parameters. One is bucket size and second one is refill. Suppose if you have a bucket here and you have a refiller that will refill the bucket. For each and every request, it will take 1 token per request. So this is the token bucket algorithm. Now there will be some pros and cons of token bucket algorithm. So if we are talking about the pros of token bucket algorithm, so it is easy to implement, it is memory efficient, and it allows burst of traffic in a shorter period. If you are talking about the cons, there is only one cons. I'm thinking like it has 2 parameters, so it is very difficult to manage these 2 parameters. So now the second algorithm is leaking bucket algorithm. So leaking bucket algorithm is also very simple. It is using queue. It means it is using FIFO system. So when any request will come, it is checking the queue. Each queue bucket is full. If bucket is full, then request will be dropped. If bucket is not full, then the request will be added in a queue, and then those requests will be passed to the server. In this example, we have 5 requests, and here we are implementing the queue mechanism, leaking bucket algorithm. So it is checking that each queue bucket is full. If it is full, then drop the request. If not full, then add the request into the queue. So when first request will come, request 1, the queue is empty at that time, so the request will be added, because so the request will come to the first place. Now when second request R2 will come, it is checking because the bucket size is 3 here. So is it full? No, it is not full. So it will add into the queue, then increment the token in the bucket. So it will be 2. Now the third request will come. It is checking each bucket is full. No. Then it will add those requests and increment it. So it will be 3. And the bucket size is also 3. So when fourth request will come, it will check each bucket full. Yes, it is full. Then drop the request. When fifth request come, check bucket is full. So drop the request. And after time interval, it will be reinitialized, means buffer will be empty. To implement this mechanism, we have to use two parameters. One is bucket size and the second is outflow rate. How many requests will be processed at a fixed period of time. So if we are talking about the pros and cons, so pros is that we can implement it easily and the requests are processed at the fixed rate. So it is stable. If we are talking about the cons, we have to maintain two parameters. And the second cons is because we are using queue. So if suppose the old request not processed because of any reason or might be the failed. So in that case, the new request will be rate limited, which is not correct. So the next one is fixed window counter. In this algorithm, we are dividing the timeline into a fixed size of window and we assign the counter for each window. When any request will come, it increase the counter by 1 and when counter reach to the predefined threshold, the request will be dropped. Otherwise, the request accepted and it will be reached to the server. So there is a major issue in fixed window counter. It allows more requests to go through at the edge of the window. So this issue will be fixed with the sliding window log. So in sliding window log, we are keep tracking the request of the timestamp such as sorted set of the redis. When any new request will come, we are removing the outdated requests. Outdated timestamp, it means those older than the start of the current window. Then we add the timestamp of new request to the log. If the log size less than equal to counter, predefined counter, then we accept the request, otherwise we reject the request. So the request will be dropped. Let's take an example. So suppose a new request will come at 10001. So at that time the log is empty. It means it will allow the request and this particular timestamp will be added to the log. And suppose the allowed count, it means the predefined count equal to 2. Next request at 10038 seconds. So it will insert those timestamp. And after that, it will check the log size, the counter. So the log size is 2 and the count is 2. So it means the log size equal to count. So it will allow the request. Suppose the next request will come at 10050. So it will insert the timestamp and then check the log size. So here the log size is 3. It means log size greater than count. So the request will be rejected. Now suppose the next request will come at 10140. So here the time range should be 10040 to 10140. It means whatever the request comes before that, it should be removed from the list. So this is the latest time frame. It means the older times will be removed, like 101 and 1030 will be removed from the log. So the timestamp list will be 1050 and 10140. 10050 and 10140, because 100 and 01 and 10030 will be deleted from the list because it is outdated. So the edge case will be covered with the sliding window log. So the next algorithm is sliding window counter. This is the hybrid approach with fixed window counter and sliding window log. Fixed window counter is not a robust solution, whereas sliding window log is a robust solution, but it enforces the hard time limit on every time window. So it is not memory efficient solution. In sliding window, we don't know that how many requests are in. So for this solution, we have to calculate the weightage of the previous time window, then estimate that how many requests are in current sliding window. So assume the rate limiters allow 7 requests per minute. So you have 5 requests of previous minute and 3 requests of the current minute. So this would be 70%, this would be 30%. And this is the current time. So when new request arrives at 30% position of current minute, then we have to calculate the number of requests in the rolling window. And how we can calculate? So here is the formula. Request of current window plus request of previous window multiply by overlapping percentage of the rolling window and the previous window, which is 70%. It means 3 plus 5 into 70%. 6.5. And if we are rolling it up, so it will be 6. So currently we have a 6 requests and the limit is 7. So we can take 1 request here. So this is all about the algorithms which we will be using for rate limiting. So what we covered till now, we covered the definition, we covered the benefit, then where we can put the rate limiter, then all types of algorithms we covered. So this is very long video. I'll take these all topics in the next video. So we'll continue this video. So if you haven't subscribed this channel, please subscribe it now and press the bell icon. So whenever the new video will be uploaded, you will get the notification. So if you like this video, please hit the like button. Thank you so much.